Let's jump into a little bit of an introduction. I'll give mine and I'll pass it on to Bertrand. My name is Robyn Dalgleish. I'm a solution architect at Rangle. We help level up teams, and our aim is to remove ourselves from that and have them be just amazing on their own. Yeah, and I'm happy to chat today, and I'll pass it over to Bertrand to give an introduction to himself.
Absolutely. So my name is Bert. I head up strategy here, and I lead the teams that help our companies make decisions, choose frameworks, and find a path to success in whatever they're trying to accomplish. We're really into static site generation and server-side rendering as a solution, and we felt that in the Angular community we don't talk enough about it, and so to try to voice that and jump in and hopefully provide something that's interesting, useful to solve some of the problems you guys may face trying to build apps. So we'll be covering static site generation, which we'll refer to occasionally as SSG, and server-side rendering as well. And we'll kind of cover the difference between the two as we go through this process. On the right side is an app that's built using some of the methods and some of the patterns and tools that we'll be discussing. For this demo, it's a very simple site. You can see that it's what you would expect from an Angular application. It's interactive. There's hover states, the header changes. You can click links and see it navigate instantly. You can kind of navigate back home, and there's inputs and everything. So on the surface, it behaves exactly like every Angular application you would have seen or written. But what's special about it is largely every page that you saw there was statically generated or generated on the server. So we'll go through how we built this and sort of what you should know to get started on that journey should you need to. So I'll get us going. And so there are three parts to this intro. One will kind of spend a few moments just covering why speed matters. I think a lot of the people in this room probably already know, but I think it's usually useful for us to just go over it and provide a sort of a way of understanding when, especially why we're having this webinar to begin with. We're very obsessed with speed, and we'll talk about why we're obsessed with speed. And the truth is, we found that static site generation and server-side rendering are essential tools in our toolbox to achieve some of the performance that we need to achieve in our applications. In order to get speed as a result, we have to apply different rendering strategies. The default, and what we see in most Angular application, is the client-side rendering. And so we'll cover the other two, SSG and SSR. I'll give you guys a quick intro to a meta framework. It's a framework on top of Angular that makes building these applications super easy, super fast, and super enjoyable, which is a big deal. And we'll talk about why that's also a big deal. But overall, we hope that you will take away a better understanding of how to build essentially the highest performing Angular application that you possibly can. So on that note, why does speed matter? Speed affects users. This has been studied over and over again. The smallest increment of time that we can discern as human beings is around 100 milliseconds. Beyond a second, we tend to lose kind of our focus on the task, and our eyes start to wander. Beyond 10 seconds, we tend to abandon tasks altogether. So speed has an impact on the user, even at the scale of 100 milliseconds. And I think that's the thing that a lot of people, I think, intuitively understand, but I think it's something else to really see it in practice. And we've seen this over and over and over again in our work. The other thing is that speed affects your SEO. So Google uses page speed as a ranking factor when it comes to ranking on pages. And it looks at a few key metrics. One of them is LCP, the largest contentful paint. That refers to the time between the page starting to appear and it essentially displaying something that looks, at least above the fold, looks full. Their benchmark for good is under 2.5 seconds. The other thing that they look at is what they call first input delay. That's the time between the page seeming to have loaded and being able to actually interact with it, meaning filling in a form or clicking a button. So when the user sees the page, has appeared to load, they'll try and interact with it. And this is where this gets really important, that good is around 100 milliseconds from that moment, because that's really what's perceptible to the user. What usually stops this score from being very good on most sites is the fact that when the application loads, or appears to have loaded sometimes. All the JavaScript hasn't run yet. It's still being processed by the browser. This is sort of one of the key things. And so pre-rendering helps that a lot as well. And then there's cumulative layout shift. You see this a lot in client-side applications where different pieces of the page are loading one after the other. The view that the user sees keeps shifting and moving. This is actually probably most impactful on mobile, but we also see some impact there in terms of desktop. The cool thing about, again, the things that we're going to talk about is that they really address these 3 key points and are really an effective tool to kind of help score higher in these categories. And finally, speed affects the actual business that you might be working for or running yourself. There's a study 10 years ago where Amazon found that every 100 milliseconds, so that 100 milliseconds coming up, cost them about 1% in sales. This has been reproduced over and over and over again. We do a lot of testing with our clients, and we've also seen similar impact. Akamai released a study just a few years before COVID, so that counts as what, yesterday? That shows that every 100 millisecond delay in website load time can hurt conversion by around 7%. The root cause for this shift over the last decade and a half is really mobile and the increasing expectation that customers have. What we take from this is that almost every year or every few years, customers' expectation of site speed and site load just goes higher and higher and higher. So that's really why we're talking about this today. This is why it's so important, and this is why adding this to your tool belt might be useful. All right, so let's talk about rendering strategies, because we've been kind of talking about SSG and SSR, and I think I wanted to put that into context. So the default in Angular, you run the Angular CLI, you create the app, is that on initial load, the app is not rendered. There's the index, there's the root, and what happens is that hydration occurs once the browser has downloaded all the Angular files and the assets, and that's when the app becomes active. So this is the common scenario. SSG and SSR are all methods of pre-rendering. So in this case, we're not going to send the user, in any case, a blank page. We're going to do some work ahead of time and pre-render the HTML. So what we're going to actually do is send the HTML of the page that they're requesting. Then the JavaScript is going to load during the hydration, and then everything's going to become interactive and active. So in this case, when I refresh on the right side, what the server did there is send everything to already fully formed. You saw very little in terms of layout shift. And then once the JavaScript was there, hover started working and clicks became available. So this is really what we're going to be talking about today. How do we actually do that, and when do we do it? I love acronyms. 2, really. They're really close, SSG and SSR. The first method of pre-rendering is static site generation, SSG. SSG refers to rendering at build time. What we do there is when we're building our application, this could be in the CI/CD, this could be locally, but before sending it to the server, we're going to go ahead and generate the HTML. And then when the users request it, they get that same HTML sent to them every single time. Because we already have the HTML, it's really fast. We can cache it. And once they have it on their local browser, they see a page loaded instantly, and then it becomes interactive within 100 milliseconds, which is exactly what we want, thanks to Angular's hydration. Further to that, we have server-side rendering. Server-side rendering is a bit different. In this case, the HTML is actually generated at request time. We don't do this on the CI/CD pipeline. We have a server, and when somebody asks for the page, we just go ahead and generate the HTML and send that HTML down to them. When we look at when we would use server SSG or SSR, it really depends on what we're trying to build. Our general advice is to use SSG whenever possible. So think of when you have marketing pages in your applications. Think of when you have blog posts in your applications. Think of when you have product listings in if you have a commerce application. All these are really great tools for static site generation. A page like this, for instance. Since everybody's going to receive pretty much the same page. And then when it becomes interactive, it can go ahead and load some of the more dynamic pieces like price or any experiments or any car count. In the case of SSR, you really want to use SSR when you can't pre-render ahead of the user's request. This happens a lot in cases where the users are actually getting either very, very oftenly updated data, or they're getting something that's very specific, an account page, for instance. The key thing to remember is that both these strategies can be used in the same app. So one page can use static generation, and the other can use server-side rendering. In any case, they're pre-rendered, but some are rendered at build time, and some are rendered on the server. And so you can mix and match them as you need to. So an About Us page can be completely pre-rendered, and the accounts page can be server-side rendered. So let's talk about this in the context of Angular, however. So the problem, and the reason why we put this together, is that we don't see enough SSG or SSR Angular applications in the wild. When we talked to some of our clients and some of the people in the community, we heard a few key facts, and they all came back to that it's actually quite hard, and the developer experience to not only set it up but maintain it is actually quite excruciating. You know, when you're setting it up using Angular Universal, which is what Angular provides, you have to think about how to do the pre-render, how to do the server side, how to tell the framework to do one or the other occasionally. And in the process, because you're rendering this on the server, it's also getting the data on the server. So the DX around how do you actually write API routes to make this all work is also quite convoluted sometimes. And as a result, we've seen a lot of people who have Angular everywhere else actually start using Next.js for certain applications when they need to server-side render or statically generate. And we think that's kind of a shame. And so luckily, the community has been working on the solution outside of the Angular core team. Brandon from the RxJS team is leading this effort, actually. There's a framework called Analog or AnalogJS, which is a sort of meta framework on top of the Angular framework. And using Analog, you can support SSR, server-side rendering. You can support static site generation, all with a great developer experience. And on top of that, you can also create API routes to create that sort of full application experience on top of Angular. I'm going to show you guys what Analog looks like, how we used Analog to build the site on the right side, and hopefully sort of provide maybe an entry step into using SSR or SSG in the world of Angular. This is actually very fast and very short. The framework is actually really powerful. So to start, there's a scaffold. You run an npm command or a yarn command, and it's going to set up what is essentially a standard Angular application with the server parts already configured. I want to draw your attention to the main.server.ts over here and their server files. So this is exactly what you would get from Angular CLI, but it's ready to take on some of the heavy lifting that you'd have to do yourself usually to get server-side rendered or to get statically generated pages. So it's that easy, and I'll kind of try and show it to you guys and prove it to you guys with some code. The first thing, there's a few things you need to know about Analog to get started, and we'll cover those few things. There's only a few. So one of the cool things about Analog is that the way you define an actual path or an actual URL. So a page that's navigatable, Analog takes control of the router for you. This is very important. It's what allows it to know how to serve SSG pages or SSR pages and when to do it. So it takes care of the router for you. And if you use Next.js, this is a pattern that's very familiar to you. All you have to do is under the source app pages directory, you'll go ahead and export certain files. So you'll create TS files under that directory, and the path itself becomes a URL. So in this case, I have two files. You can see that they're the ones that have the dot page. One is the index. This is what you're seeing here on your right. And one is a little strange. We'll talk about this one, but it says roomid.page.ts. And it's really this page over here. It's a detailed page of some of these rooms. You could have an about.page.ts, and that would route to about. You can have a contact.page.ts underneath here. So very simple. It's a quick mapping. Nested routes are also simple. You just create a folder. So all that this does is that instead of my page for the room being under the root of my domain, in this case, it's under /rooms/something. You can nest this infinitely long. I don't know why you would want to go further than 16 or so, but you can if you really, really, really want long routes. I talked about this a little bit. This little strange square bracket over here. This is a way of creating dynamic routes. So I have a different page for each of my rooms. I have signature room over here. I have a deluxe room, and I can see the data for the deluxe room. What this square bracket is going to do is route anything that's a /room/anything. So in this case, I'm going to be passing a /1/2, whichever room ID. And it's going to make available to the page as a query, as a route param, as a page param, a variable called room ID, and I can use that to fetch from the database or the CMS, the actual room that I want, and I can render that. So this is very powerful. So I can create any sort of dynamic system and have that actually work from a server-side perspective, but also from a static side perspective. The other thing that I want to point out here is that there's another folder called server. Underneath this folder, you can create APIs as well to fetch data. So you put that under server.route, and they'll appear under /API/whatever the file name is. In this case, it's rooms. It could be anything. And so you can kind of put your endpoints here as well. All very easily. This is all managed. When you deploy this, you'll have your API deployed, and you'll have your pages deployed as well. And we'll talk about how those look. And finally, there's also this little file called bit.config.ts. I'm just noting it. We'll talk about it at the end. Once you have a page, this is what it looks like. Everybody here who's done Angular will recognize this. It's a standard Angular component. This is our index page. This is the home page. You can see that we have an app hero with a slider where the background is changing every 3 seconds or so. We have a booking form, which is this little guy in the middle. And then we have a list of rooms. And so this is a page that you would have written a million times before. But just because you wrote it under the source app pages repo, it is now being server-side rendered by default. There's nothing else to do. This is the developer experience that we've been talking about. So all done. In a way, this is very similar to if you've ever built HTML files or PHP sites. But instead of just using PHP or HTML, you're just writing it in Angular. That is it. Once you have that structure that we discussed, and you put these under the page, these are going to be server-side rendered. When a user makes a request, your server is going to go ahead and generate the HTML and send it down. And once it's down, it'll start working. A carousel will act like a carousel. A form will act like a form. And the rooms will act like rooms. And they'll have all the flourishes that you want, including sort of CSS animations like that. So that's all you have to do once you have analog set up. And the rest of your application is going to be very much the same. We've seen people migrate fairly big applications without barely changing any code. It's very cool. It's very powerful. I mentioned app routes. So if any of you are familiar with lambdas, again, this is a simple TS file that you export. And once you export and you deploy it, it's just going to run and take events from the API route. You can change the route. You can make it services. You can make it anything you want to be backwards compatible. You could add along the route, you can add API versioning, v1/. But really, it's a function that could be asynchronous or synchronous, but most of them are asynchronous. You can do whatever logic you want here, such as fetch a room from a database or a CMS, and then return it. And this will create a JSON API. And that comes just from putting this TS file in that server route. And suddenly we have server-side rendering, and we have API routes that our server-side rendered pages can hit to get, for instance, a list of rooms to render. It's very fast. It's very co-located, and it works like magic almost. We've also seen people use this to just proxy other APIs. It's very popular for front-end teams to write their own APIs to back-end APIs. Finally, the last piece of the puzzle is, if everything is SSR by default, how do you get SSG? Meaning, how do you do it at build time rather than doing on the server for those pages? And that last file, that bit.config.json, that is the file. So you can go in there and you can define all the routes that you want to be pre-rendered. And so instead of those routes being server-side generated, they're going to be generated statically at build time. You can see that you can write like the about page, the root of the blog, but you can list every single page you have, such as an actual post, and see that statically generated. And every page that you don't list here will be server-side rendered. Regular routing module is under the hood. In fact, you can use the link router, you can use everything. That's what I'm using over here. You just don't have to define the mapping of your routes. The framework takes care of that. It'll infer them from the directory structure. You can always escape as well. Don't know what you would, but you can. You can always grab it. It's always there. It's right under the hood. We've seen people set up analytics tied to the router and the Angular router, and that's worked with barely any change, which has been very cool. And yeah, surprisingly, that's it. You've now learned how to write an SSG, SSR Angular application in about 20 minutes.
You got this.
So we can't wait to hear about you guys going out and trying it and succeeding and telling us all about it, or complaining about something that you didn't like, and we'd like to hear those experience reports as well. So I'll stop there.
And so from Greg, typically SPAs are statically served with something like NGX. How are these SSG, SSQ sites served? SSR, I think it was a typo.
This is actually pretty cool. So underneath the hood, Analog is built on a technology called Nitro and Vid. And the combination of this is that one thing to be mindful of in terms of server-side generation is that it requires a server to be running. Most people will do a build and send that build out to CDN or storage. In this case, you can still do that if you want to statically generate everything. But for the server, you need a server to be running. What's cool about the server that would be running this is that it's already included in the framework. So when you run a build and a deploy, which we haven't covered because of the time constraint, this application will run without any configuration on Vercel, Azure, CloudFlare, and Netlify, and with a little configuration on AWS, DigitalOcean, Firebase, and Heroku. And so there's a little bit of configuration to make it work on some of these other platforms. But really, the way to think about this is you'll run a analog build, and then you'll deploy the bundle that has these configurations for these platforms already in there. Does that answer your question?
So normally, right, when I think of a single page app, I deploy it, for example, to an S3 bucket and just tie a domain name to it, right?
Yeah.
There's no VM, there's no server, so it's really cheap. It's really inexpensive for me to host it and let the browser run the application. That doesn't sound like that's the case here. There's going to have to be some sort of a VM or some kind of an application that this is sitting on, because that code is being executed remotely and not within the confines of the browser, right?
Yes, with an asterisk. You could, for instance, take this application, put it in a Docker and deploy it, and then you have a runtime cost as well that is different than the one you would have from your storage bucket. However, and sort of where the world is going in terms of server-side application, in practice, people deploy these applications whether on AWS, Azure, or Vercel, or DigitalOcean, or anything like that, they're deployed in serverless Lambdas. And so there's not a server running all the time. There's a server that runs when a request comes, generates the page, and sends it. The thing that you're used to in terms of the bucket, how cheap that is, it's a bit more expensive, but you get the speed,
Right,
and
'cause you're
hopefully the
running
business
Lambda
benefits,
function.
but they're Lambda functions. So you're not doing provisioning, you're not managing servers, you're not doing any of those. And so this is really great. And we may do like a part 2 that goes over some of the details of this. But one of the coolest parts is that when you use Vercel, for instance, and AWS, you can use the edge Lambdas as well. So it's really close to your end customers, really reducing latency. We've used these CDNs a lot in some application domains, and we've been able to hit latencies that are even double digits milliseconds in terms of that first byte that they see. So Lambdas is the short answer, and then the answer that I just gave is a long answer. I see a question from, you can definitely deploy this to Azure. There's definitely documentation. We'll make sure to send that to you. You barely have to do anything. Azure is one of the first class supported platforms for analog, along with Vercel, CloudFlare, and AWS. We've actually deployed this exact example on Azure, so you'll be able to see how that looks like. It uses Azure very effectively. It can use Azure functions. You can deploy it to Azure. Azure has a few other sort of hosting services, such as, I think it's called Web App or something. Anyways, you can use all of those options.
So the application I work on is probably the antithesis to static. It's a customer portal, essentially. When this is deployed in something like Azure or an AWS for SSR, HTML is generated request time, because essentially almost every single page that I would have to work on would have to be rendered because it's specific data to a particular customer. What's the benefit there? Because I imagine there's some difference in latency between a browser making an API call versus the server making the API call and then rendering it. But the browser still has to render all of the HTML. You'll maybe not get so much CLS, but is the juice worth the squeeze?
Thanks for asking that. I did miss that one point when I was going through this because I was so excited about SSR and SSG. But I think it's worth talking about when to stay client side. The use case that you describe, if it's a dashboard, for instance, or heavily data intensive application that is very sort of different per user, I think in our experience, it's not. These things tend to be behind some kind of login wall, so there's no SEO benefit. And beyond that, they tend to make a lot of calls. And all the calls are very specific to that one user. So in these cases, it's less valuable. The dashboard use case is the one that we find where we say just start client side. Don't add any complexity to your stack from that perspective. The only caveat is those API routes will never be client side. They're always server side. And Angular provides what's called state transfer, meaning you're gonna maybe make a lot of database calls to a bunch of different systems. And those systems, for some reason, are faster on your server than they are on the client by a margin that is worth it. So in other words, if you're seeing performance due to front to back latency, you might consider it. We've used in the past GraphQL to solve some of those issues in terms of making a lot of round calls using HTTP2. So again, this is my long way of saying for those dashboards, just stay with client side. For everything else, you should definitely consider this. I'm guessing the application you're working on, does it have a marketing site for the login?
Well, there's a multitude of applications where I work, and there are marketing aspects to it. The application that I work on is all behind a login, and those API calls are being made to internal systems that currently are not cloud hosted. at least not on a public cloud. I don't believe SSG or SSR will work. I think there's other applications within the organization where it could.
We do have another question as to when there might be a stable release.
So a note on why it's in beta. It's not in beta because it's not being used. It's in beta because the APIs and that there's still a lot of functionality that is coming in, and that functionality may cause breaking changes. So the thing to understand about Analog is it's a meta framework. So underneath the hood, it's using Angular 16 or Angular 15 or whichever Angular version you're in. All that is very stable. A lot of what Analog is on top of this are a set of tooling. While they're still in beta, it is used in production. The stable release is expected later this year, but it all depends on the feedback of the people who are using it currently. But yeah, it's not beta in the sense of it being sort of broken or anything like that. A lot of the things here, I think, with the team that's running this and the sort of maybe the lessons that they've learned in the past is really around API stability. We've had no problems with it so far. And the errors actually, when they happen, they do make sense. That's a win in my book versus the old CLI. If you guys remember that time.
It's been awesome engagement. Thank you, folks. Anything else?
Well, thanks everybody for joining us. Go ahead. Sorry, I stole your thank yous.
Thank you so much for joining. Thank you so much for your questions. It's been fantastic.
Yeah, and if there's anything we didn't cover or we didn't cover deeply enough that you really wanted to see or hear and it just didn't make sense to ask us, feel free to send us an email, ask for it. We're happy to provide anything or any help there.
Great. Thank you, everyone. This is great. All right. Have a good day.